On December 19, 2007, a devastating explosion tore through T2 Laboratories, a small chemical manufacturer in Jacksonville, Florida. The blast killed and injured workers, obliterated the facility, and damaged nearby businesses. Shattered windows sent glass flying through nearby offices, injuring those inside. The T2 incident is one of several tragic cases the CSB has investigated, all caused by runaway chemical reactions. These types of accidents are far too common, and often deadly. Behind me once stood a 50-foot-tall structure, home to a reactor where T2 manufactured a gasoline additive called methylcyclopentadienyl manganese tricarbonyl, or MCMT. That entire structure was destroyed in the explosion. T2 made MCMT in a 2,500-gallon reactor. Operators controlled the process from a nearby control room. The procedure began with loading liquid chemicals and sodium metal into the reactor. They were heated and mixed, releasing hydrogen gas, which was vented away. Normally, when the reactor reached 300 degrees Fahrenheit, heating was shut off. But because the reaction continued generating heat, known as an exothermic reaction, temperature kept rising. At 360 degrees Fahrenheit, workers began adding water to a cooling jacket around the reactor. As the water boiled, it removed excess heat. But on the day of the explosion, something went wrong. The cooling system failed, possibly due to a blockage or a valve issue. The reactor's temperature and pressure spiked uncontrollably. The plant's co-owners rushed back after being alerted to the issue. One searched for maintenance help, the other headed to the control room, warning staff to stay away from the reactor. But inside, the pressure kept rising, eventually reaching 400 psi and blowing the rupture disk. A loud hissing noise signaled gas escaping. Just seconds later, a massive blast occurred, equivalent to 1,400 pounds of TNT. The explosion caused damage over 1,500 feet away. Debris traveled up to a mile. 4 people died, including the co-owner and an operator in the control room. 2 others succumbed to debris injuries. 32 others were hurt, most of them in nearby offices. The plant stored numerous chemicals, all burning together, a nightmare scenario for emergency responders. When dealing with exothermic reactions, it's crucial to understand how much energy might be released, otherwise, vessels can rupture catastrophically. T2 developed their process using just a 1-liter lab reactor, then scaled it up directly to full production in a 2,500-gallon tank. Later, they increased batch sizes by another third. As batch sizes grew, so did cooling challenges. Over 175 batches, T2 repeatedly faced temperature issues, but never thoroughly investigated the causes. Normally, when the reactor reached 300 degrees Fahrenheit, heating was shut off. But because the reaction continued generating heat, known as an exothermic reaction, temperature kept rising. At 360 degrees Fahrenheit, workers began adding water to a cooling jacket around the reactor. As the water boiled, it removed excess heat. But on the day of the explosion, something went wrong. The cooling system failed, possibly due to a blockage or a valve issue. The reactor's temperature and pressure spiked uncontrollably. Their cooling system relied solely on city water, with no backup. When it failed, disaster followed. Managing reactive chemistry means fully understanding how reactions behave under all conditions, not just the expected ones. To avoid such tragedies, companies must identify and evaluate reactive hazards, install proper safety systems, and train their staff. Plans should include emergency response drills and process safety reviews. Despite their education, T2's founders lacked training in recognizing and controlling reactive hazards. Many accidents happen because those running the process aren't fully aware of the dangers, or the scale of potential consequences. Resources exist, like those from the Center for Chemical Process Safety and others, to help companies manage these hazards. Following this investigation, the CSB urged chemical engineering programs to include reactive hazard training in their curricula. Reactive chemical accidents are still too frequent. Better practices and better education can prevent future tragedies. Thank you for watching this Engineering Spark video.